Alright guys, this is going to be another video for the 949550 GT Cobra guys. So this video is going to be about cooling, what parts of the cooling system are involved on these cars, more so on the electrical side. So starting off here, right here next to the thermostat housing, this piece right here, threaded into the heater hose. I forgot what it's called, but the pipe that goes to the heater hoses, that right there is called the engine coolant temperature, ECT. This is what reads the temperature for the PCM, for the computer. It tells it where what temperature the engine's at, and it moves it out of open loop, cold loop. It allows the computer to advance timing, retard timing, add fuel, lessen fuel. And as you can see, it has a 2-pin connector. This one you could thread it in and out of there. Just put some Loctite sealant on there. This one over here, where is it? This sensor down here, not sure if you could see well. But it's a sensor with a pigtail. Not sure how well you can see it, but it has a 90-degree fitting on there. That one is called the temperature sender. That is what sends the signal to the instrument cluster on the dash. And this one is a more so of a thermocouple, you could say. It just moves with resistance with heat. So as the heat comes up, inside is there like a little needle that connects the ground from the engine block to this wire, and therefore allows the needle to move up and down according to the temperature of the engine. That one is a temperature sender. So when you guys are seeing cars that are saying, oh, it's overheating, I already changed the temperature unit and it doesn't work, it's this one that reads for the dash. This one over here reads for the computer. Following here is the 2-speed fan, high and low. These fans work good for a stock car. Here you can see it's a 3-pin connector. Most of the times when your fan is not coming on, it's due to the connector here. One of these or two of these will be burnt, either here or the connection here on the plug. And the reason that these fans start to burn up is they start to pull too much current, too many amps. When the bearings inside start to go out, to move that fan, it puts more load on that little motor and therefore pulls more amps. This, I believe, has a 60 amp fuse. So the spike upon startup is the one that jolts the electrical system and the charging system. As you can see, it'll start wearing out the motor. Then if it's too bad that it heats up this part, it'll start heating up this connector and it'll start melting, and it's a possible fire hazard if they melt and touch, as these are high current wires. The next part is this box right here, called the CCRM, the constant control relay module. Here it houses the high and low speed fan relays, the PCM relay, the fuel relay, and the air conditioner relay. So it's about 5 relays in this box. If everything is working well, this box should be functioning as well, turning on the fans on and off, high and low speed, according to what the PCM reads. And when you turn on the air conditioner, it should kick on the high fan. And if you see that this sensor is good, the fan is working good when you put 12 volts to it, the connector's not burnt, then most likely it will be the CCRM inside. Usually the relays fail over time from heat, and the only way changing it out is getting a replacement. I would opt for a used one. The label for the sticker of the part number is going to be on this side right here. It's just covered right now by the coolant bottle. And what I've seen some people do is they bypass this and they run a positive wire from here to a switch inside and to the positive of here. That is the wrong way to do it. That's asking for trouble, asking for a fire hazard right there. Because the reason Ford went this route with a constant relay module is that you need a fuse. A fuse and a relay work in conjunction to stop the spike of the fan coming on, versus a switch sends all the power straight to the fan. And that's how fires start. That's how heat happens. And you always want a control side, and you use a relay for that. So I would never suggest jumping it inside a switch to the fan unless it's an emergency and you need to get home. But that's the wrong way to do it. You'll want to have this car running as well. You're gonna need to bench test the fan, applying 12 volts to it. Make sure that this connector is not burnt. Make sure that this temperature sensor is good. There's on the forums the resistance values. When you unplug this and you read the temperature of the engine, they should put out a certain amount of resistance or ohms. So for example, if it's up to operating temperature, this is just an example, I should say 50 ohms, but when it's cold it should say 25. Again, these are just an example, but it should read like that. When you unplug this, you have to have this unplugged, because if you connect the multimeter with this unplugged, you might damage the computer. So it's just best to unplug it and touch the two pins in here and just test the sensor values. And then the last thing to check would be the CCRM. You can bench test it. There are ways according to forums online, and a quick way to tell if it's working or not is you could open it up. As you can see, right there's a rivet. On the other side there's another rivet. Open it up and see if there's burnt marks on the circuit, or if there's water intrusion, or if it's just over heat cycles that the solder inside melts and you get a cold spot, and therefore the relay does not work. The relays are changeable, but since I've seen Radio Shack has gone out of business, those aren't readily available anymore. You might be able to get one at your local electronics store. But yeah, the 5 main components are the ECT sensor, the one that sends the power to the PCM, the temperature sender, the fan connector and its pigtail, and then the CCRM. Last thing to do that you could check is the PCM outputs at the PCM. But again, if there was an issue with the PCM, it would most likely put a code, or it'll have other issues running the engine. So most likely it's 9 times out of 10 it won't be the computer. It's going to be one of these circuits here. And that's just a basic overview. I hope it helps. It keeps you in the right direction, and it's just a warning for you guys that say, oh, just bypass this system. The Ford engineers designed this as a safety system. Even though you might think, oh, it's 90s, it's old. I mean, it's way better than running a switch under the dash and then to the fan and risking getting a fire or burning other electronics up. So I hope this helps, and hope you guys end up finding this video useful. Please like and subscribe and share. Thank you very much.